Assalamu alaikum, dear students. We are starting with the last lesson 5, the last lesson. In this lesson, we have around 6 questions coming, and even then, in the last lesson, which I mentioned, like question number 20, even 21 is connected with that lesson as well. Okay, and when you go through the learning objective, you can understand that question number 20, 21, and 25 is connecting the same concept. Okay, some connected with the calculation, some connected with the definition and concept checking. Okay, and case number 22 is connected with the impulse. We already discussed about that. And question number 23 is connected with the closed and isolated system. It's an easy question. And question number 24 is connected with the conservation of momentum. Okay, so let us go to discuss about the topic or concept in detail, and then we'll have a discussion about the question. See, first and foremost, we will be discussing about angular momentum. We must remember by now the linear momentum. What was linear momentum? P, that is equal to mv. But this is normally in linear motion. When it comes for the rotation motion, what we have, mass will be replaced. Like momentum will be angular momentum, okay, and the mass will be moment of inertia. I will be moment of inertia, and v will be angular velocity. This is moment of inertia, and omega or w will be angular velocity. Angular velocity. So try to understand angular momentum L will be equal to I omega, and again over here they are asking us to specify its unit. Okay, it's very much needed here also. Like this is the second question which is connecting the SI unit of the system. Okay, and listen very carefully. See, angular momentum, as we mentioned here, it will be calculated I omega. What is I? Moment of inertia. We know that moment of inertia generally we calculated with mr square. So it will be having a unit of kilogram meter square. Okay, and again what we have, we have omega. See, omega basically is having a SI unit just 1 by second. Okay, so you multiply this with 1 divided by second. So altogether what you will get, kilogram meter square divided by second. So this will be the SI unit of it. Okay, as we discussed in the previous situation, like we were having momentum, then we connected with a momentum impulse theorem, right? What was momentum impulse theorem? Force into delta t, this is the impulse, will be equal to change in momentum. Okay, so there also we connected with the angular momentum. There we can connected with the impulse and momentum, and this is impulse momentum theorem. Similarly, in rotation motion also, what we have, we have angular impulse and angular momentum theorem. See why I'm addressing it right now? Like, see, it is very important to recall or remember the other unit of angular momentum. So how do we connect it with or angular impulse? See, look at angular impulse or angular momentum is connected with each other. So according to the equation, tau into delta t. What is tau? It is the torque. Okay, torque is the rotation force. Okay, rotation force. So what is the SI unit of this rotation force actually? This Newton meter. So Newton meter into second is exactly equal to change in momentum. Change in angular momentum. So change in angular momentum will be equal to Newton meter per second. So Newton meter, another unit, let me just connect it with another Newton meter, together I can call it as joule. Okay, joule second. So look at, see, using this equation I can very well say that angular momentum can be having or can represent with a different SI unit. The first one, kilogram meter square divided by second. This is the first unit. Okay, from the very non equation we can very well connect it with. The second equation, look at the second equation which we mentioned over here. It is change in momentum is exactly equal to what, angular impulse. So angular impulse is torque into delta T. Torque, we know its SI unit will be Newton meter. So I can very well write the second unit will be Newton meter into second. And what is the next one? Newton meter together I can call it as joules. So joules into second. So this many units are there in connection with the angular momentum. So they are bringing questions in connection with this. So we can expect it. Okay. Now let us go to the next idea. Again, let me recall it. Like angular momentum is rotational equivalent of linear momentum. So in linear momentum, it's P is equal to mv. Over here, angular momentum L is equal to I omega. Okay, I and omega. Now look at, see, question number 21 is connecting exactly the same. Like you have to solve the numericals connected with the angular momentum. Okay, and you need to consider the conservation of angular momentum as well. Okay, so let us discuss about the conservation of angular momentum. Like, look at, as you can see over here, this is a skater who is skating like by stretching her arm and leg away. So over here, what is to be noted, this is the axis of rotation. Like the radius from the axis of rotation to the edge of the body is more, which means its moment of inertia will be more. If moment of inertia is more, according to the conservation of angular momentum, angular velocity must be less. So what is conservation of angular momentum? See, conservation of angular momentum is nothing. Angular momentum before and angular momentum after an action should remain same. So this is a situation which I just connected with. Look at, we have two situations. A skater who is stretching her arm outward and stretching her arm inside. See, what is more important, over here on the skater, we are not giving any external or external torque. There is no external torque given to the particular object. If no external torque has been given, the angular momentum before and the angular momentum after must remain same. Okay, so let me connect it with some number. See, over here, the angular momentum is 100. Initially, she is stretching her arm outward. So let me say the moment of inertia over here, it is just like 25. Okay, moment of inertia is 25 over here. She is stretching her arm outward. So obviously to get 100, what it would be, angular velocity will be 4. Okay, so I'll be getting 100. Now look at, over here, she herself is doing some like force and torque inside, but it will never affect the conservation of angular momentum. Like conservation of angular momentum means angular momentum before and angular momentum after must be same. So right after bringing her arm closer, look at, see, her moment of radius has been reduced by like large, and the moment of inertia should be reduced more. Okay, so over here, let me say her moment of inertia has been brought to 10. So to make 100, what must be the angular velocity? Angular velocity must be 100. See, the moment of inertia in the second situation has been reduced. So who has been increased? Angular velocity has been increased. So this is the concept you need to think of it. I am repeating, like conservation of angular momentum is easy actually. Before and after momentum, angular momentum must be same. Okay. So if one increases, another must decrease. Okay. If one decreases, another must increase. That is the idea. Okay. Pull arms spin faster, extend arms spin slower. Okay. So moment of inertia increase, omega. Moment of inertia I decreases, moment of inertia increases. Okay. Spin faster. I increases, omega will decrease and it will be slowed down. So this key concept you just remember. Now let us see, this is the exact concept checking where question number 25 as well. Now let us do certain questions in connection with the first question. A 2 kilogram block travels around 0.5 meter radius in a circle with an angular velocity of 12 rad per second. The magnitude of angular momentum about the center of the circle. See, look at, we have a circular object which is running. See, this object is having 2 kg and it is moving around a circle of radius 0.5 meter. Okay, and what they are demanding, like as it is in a rotation motion, of course we will be having angular momentum. We will calculate L, that is equal to I omega, but we need two things. We need I and we need omega. See, as it is a point object which is more farther away from the circle, like what will be the I value? Omega they have given. See, omega angular velocity clearly mentioned it as 12 rad per second. So omega is 12 rad per second. There is no concern for that. But how do we calculate I? I will be calculated. I will be equal to mr square. Okay, it's moment of inertia. M is given, it's 2 and its radius is 0.5 the whole square. So what I can get, I'll be getting I think 2.5. Let me check, let me do the calculation. 2 into 0.5 multiplied by 0.5. Okay, so what value will get? 2 multiplied by 0.5 multiplied by 0.5 will become 0.5. So moment of inertia we will be getting it in such a way that 0.5 itself. Okay, now like I got moment of inertia kilogram meter square, and then I got angular velocity, both I got. Now what I need to do, I need to calculate L. L will be equal to I into, I is 0.5 into omega is 12. So what hopefully you will get, 6. Okay, so 6 kilogram meter square per second. Okay, so which one it would be? Kilogram, 6 kilogram. Two options are connected with the, look at, this is connected with a 6 kilogram meter square second, and this is connected with a kilogram meter square by second square. So which is wrong? See, this is not the unit. This unit is wrong. So which one is correct? This is the correct value. Okay. Now, what is the possible unit of angular momentum? Okay, possible unit of angular momentum. Kilogram meter second. This is wrong. Kilogram meter square second square. This is also wrong. Kilogram meter square meter second square. So which one it will be? Kilogram meter square second. Okay, this one it will be. As I mentioned, remember the unit of, like there are 3 units which in connection with the angular momentum. Kilogram meter square second 1, then Newton meter into second unit, and third unit joule second. Okay, all these units have been exactly representing angular momentum. Okay, now let us look at the next question. An object angular momentum changes by 20 kilogram meter square per second in 4 seconds. Okay, what is the magnitude of average torque acted on this object? See again, recall the equation which we needed. Like, see, this is a angular impulse angular momentum theorem. Torque into delta t will be equal to change in momentum, delta L. See what they have given. Change in angular momentum they have given. Delta L value they have given. Okay, and time also they have given. Time is given. Delta L also they have given. So just put the value. It is 20. Okay, and torque into 4. Okay, you take to the other side, so you will get torque 20 by 4 will become 5. Okay, so which one would be 5 Newton meter? Torque will be Newton meter, 5 Newton meter. Now the next question. Two rotating discs A and B have the same total angular momentum. Okay, angular momentum is exactly same. If the moment of inertia of the disc A is twice that of the disc B. Okay, IA, they clearly mention the moment of inertia of the first object A is twice of the IB. Okay, what is the ratio of their angular velocity? I think it's very easy. Let us write. Both of them have exactly LA and LB is same. Okay, there is no difference at all according to the question. Now, how do I calculate LA? LA I'll be calculating IA into WA. Okay, and LB I'll be calculating IB into WB. Okay, what I need actually, they're asking you to calculate the ratio of omega A by omega B. Okay, so I bring this to this side and this to the other side. So when I'm doing it, what I'll get, omega A divided by omega B will be equal to, see, this IA is going to the other side. IA is going to the other side means IB by IA I'll get. Okay. Now, let us put the value. What is IB or what is IA? IA, they said it in such a way that it is 2IB. Okay, so IB divided by 2IB, you put IB and IB you can cancel. So finally what you'll get? You'll get 1 divided by 2. So which is correct answer? It is 1 by 2. Okay. Now, see in this question, a solid sphere of mass 5 kg and a radius 10 centimeters rotate about its axis, passes through the center. Its angular velocity changes from 20 rad per second to 40 rad per second during 5 seconds. The magnitude of the net torque acting on the sphere during this time interval. So let us look at the givens. First, they have given the mass. Then they have given the radius r, okay, which is to be converted into meter. So it will be 0.1 meter. Okay. 10 centimeter will divide 100, so that I'll be getting 10 by 100 will be 0.1. Okay, and about axis passes through the center and angular velocity, see, it is starting from angular velocity starting from means it will be omega I. Okay, 2 means like it will be omega f. So omega I and omega f they have given. Okay, and then they have taken the time delta t. And what we need actually, we need we need torque. So connecting, see, mass and radius is given, moment of inertia is given, which means I given, okay, omega I and omega f is given, okay, which means delta L I can calculate. So delta T also given, and torque I need to. So which equation will be connecting? See, it is angular impulse and angular momentum theory. So what will be that? It will be torque into delta T will be equal to delta L. Okay, what is delta L? Delta L will be equal to, or torque into delta T will be equal to L final minus L initial. So how do I calculate L final and L initial? It will be I into omega final minus omega initial. Okay, so I took common, so that I final minus I initial into moment of inertia. So the problem over here, do we have moment of inertia? We don't have moment of inertia. Omega I we have, omega f we have, and delta t also we have, but we don't have I, which is given directly. But they said it's a solid sphere. Solid sphere will have a moment of inertia will be 2 by 5 of mr square. Okay, so you put the value like 2 divided by 5 into m is 5 into r square is 0.1. Okay, 0.1 square. So what I'll be getting, 2, 5 and 5 will get cancelled. So 2 into 0.001 I'll get. Okay, so into 0.001 I'll be getting 2 into 0.01. What will be the value? It will be 0.02. Okay, so the moment of inertia I got it as 0.02. Now I need to calculate torque. So what is torque? See, from our equation, like look at again, let me write it. Torque into delta T will be equal to I into omega final minus omega initial. Okay, this is our equation. Now torque, what is torque? Delta T you take to the other side. So what is moment of inertia? We found it 0.02 multiplied by like what is omega final minus omega initial. Omega final is 20 or 40. Yeah, 40. 40 minus 20. In here I'll be having delta t as how much? 5. Okay. So you just do shift and solve, you'll get the correct answer. So how much it would be? Over here in this situation, it will become 20 into 2, it will become 0.4 divided by 5 I will get. So it will become 0.08. Okay, so 0.08 I can write in such a way that 8 into 10 to the power minus 2. So 8 into 10 to the power minus 2 Newton meter. So this will be the correct answer. Now look at the next question. A large gear a diameter below rotates when a larger gear in a diagram below rotates, it turns the smallest gear in the opposite direction. Okay, the large gear rotate and the small gear also rotate in the opposite direction. That's the first initial statement which is given. The larger gear has a twice the radius of, see, radius of, let me write it over here. The radius of the larger one, let me take it as, if this I take it as r, then the radius over here it will be 2r. Okay. Okay. Now, the large twice the radius and 4 times the mass of t. So if this is having a mass m, then this will be having 4m. Okay. Now, what is the angular momentum of the larger gear as a function of angular momentum of the smaller gear? So first of all, let me calculate the angular momentum of what, smaller one. Then I'll try to connect it with the larger one. So to calculate angular momentum, I know the equation L will be equal to I omega. Okay, I omega. So what will be? I am calculating small one. So let me write it as angular momentum of small one will be equal to moment of inertia small one and angular velocity of small one. Okay. Now let me put the value of angular velocity, moment of inertia. Moment of inertia, as it is a disk, what is the moment of inertia of a disk? It is half mr square. Okay. So I'll be writing moment of inertia of small one will become half into mr square. Okay. Into omega s. Omega s is not given, but yeah, we'll come to the omega s part later. Now similarly, let me write it the angular momentum of the big one. So angular momentum of big one will be equal to I big into omega big. Okay. See, like I big, it's easy. Half into mass will become 4m and radius, it's half mr square. Radius over here will become 2r the whole square. Okay. So into omega b. Okay. Now what is to be done? Look at over here. When I'm expanding it, I'll be getting 1 by 2. I'm not cancelling anything because I need to write like one in function of the other. Okay. I'll tell you how we will be. See, 1 by 2 into 4m into 4r square. Okay. Into WB. The problem over here, this is our moment of angular momentum of the larger gear. But the problem over here, unless we are not aware of omega s and omega b, angular velocity of the smaller one and the angular velocity of the bigger one, we cannot solve this particular question. So what is to be noted, so you know that these two are contacting with each other. So when they are contacting with each other over here, this will have a linear velocity. Means both of them will have the same linear velocity. Okay. So what is the linear velocity of this? That would be exactly same as the linear velocity of the other. So we know the relation between linear velocity and radius and angular velocity. V, that is equal to r omega. Okay. This relation we have. So suppose if I just wanted to find out what will be the small, see, what small angular velocity of the small gear. So what I'll do, I'll use the same equation. V, that is equal to radius of the small one and omega omega of small one. Okay, radius of the small one is just r, and omega so. See, what I don't know, like I don't know like omega s. So what I just need to do, I'll be rearranging this equation in such a way that I'll be getting an equation for omega s. Omega s will be equal to v divided by r. Okay, this is the relation you need to remember. Okay, now what I'm going to do, this omega s I'll be putting here in this particular situation. So finally, I'll be getting half m r square into v divided by r. See, I have 1 r over here and 2 r over here. 1 will get cancelled. Okay. Now, finally, what is the final equation? For ls I am getting ls will be equal to half into m into r into v. So half into m r v I am getting. Okay. Now look at the next one. Similarly, I need to replace omega b. So omega b, how do I write? See, WB will be equal to V divided by radius of the bigger one. It will become 2R. Okay, so 2R I'll be writing. Now let me put that value over here. So again, I'll be getting half into, this 4 into 4 will become 16, right? So it will be 16 into MR square VWB. Like WB, I am replacing it to V by R. Okay. Again, 1 R I'll be getting cancelled. Okay. Now, sorry, like V divided by 2R, right? We have a 2 as well. So this 2 and 16 will get cancelled. I'll be getting 8. Okay. So final answer, let me write. LB will be equal to what? LB will be equal to 1 by 2 is there. M is there. 8 is there. 8 is there. 1 by 2 into 8 into M R into V. Okay. Now look at, I need to write LB in terms of LS, means angular momentum of the larger one with the smaller as function of smaller one. So what I do, I'll divide this with this one. See, I'll just divide LB by LS, angular momentum of big one divided by angular momentum of the small one. See, what is LB? LB is half into 8 into MRV. Okay, divided by what is LS? Half into MRV. Okay, so half and half will get cancelled. Okay, M and M, R and R, V and V also will get cancelled. We will get 8. So LB by LS will be 8. So what is LB? LB will be equal to 8 into LS. So which one it would be? LB is equal to 8 into LS. So this is the answer. Okay. According to the figure, a skater pulled her arm inward while spinning. Her moment of inertia decreases. We know the moment of inertia will decrease as it moves inside. What will happen to her angular momentum? Obviously, the relation is inverse, right? One decreases, another must increases. Okay. So over here, moment of inertia decreases, angular momentum must be okay. Moment of inertia decreases. What will happen to the angular momentum? See, they're asking for the angular momentum. What will happen to the angular momentum? Angular momentum stays same. Angular momentum will not change. Angular momentum is I omega. Even though this I is go down, who will increase? Omega will increase. As a result, angular momentum will remain same. Okay, so which one will be the correct answer? C will be the correct answer. Okay. Now again, same question. A skater spin with the arms outstretched. When she or he pulled his arm inward, raises the above his head and begin to swing much faster. What explain the increase in his angular velocity? Okay. So first, a torque act on him, increasing the angular momentum. No, there is no external torque is acting. That's wrong. His moment of inertia decreases. Okay, moment of inertia decreases and his angular velocity increases. Yes, correct. See, as he bring arm closer, moment of inertia decreases and angular velocity increases. So which one it will be? B will be the correct answer. Now, next one. A ice skater spin 2.5 rotation per second. What is this? This is F, frequency. Okay, with the moment of inertia of 0.5. So I is given and frequency is given. He then show stop in 3 seconds, okay, by dragging his skate. Which of the following correctly give the initial angular momentum? Okay, initial angular momentum you need to calculate. See, final angular momentum is easy. Final angular momentum is how much? Final angular momentum will be exactly equal to 0. Why? Because they slows to stop, it's after 3 seconds. Okay, now what will be the initial angular momentum? So how do you do? They have given the value I, and this particular omega also they have given, but omega directly they haven't given. So what they have done, omega indirectly they have given. So how do you calculate omega? Omega will be equal to 2 pi f. Okay, so it will become 2 into pi into 2.5. So omega, how do you get? You will get just 5 pi. Okay, 5 pi is omega, and 0.5 kilogram meter square is I. So what will be Li? Li will be equal to I into omega I. I will be equal to 0.5 multiplied by 5 into pi. Okay, so let me put the values in the calculator so that I'll be getting 2.5, sorry, 0.5 into 0.5 into 2. 0.5 into 5 into 3.14, it will be 7.8. So what will be the value? 7.85 kilogram meter square second. So first option will be the correct answer. Okay, this one. Now let us look at the next question. 0.25 meter diameter, a circular saw. It's a cutting board. Okay, so blade rotated RPM. Okay, 5 into 10 to the power means 5 into 10 to the power 3 RPM. Understand, this is rotation per minute they said. RPM is what? Rotation per minute. So this is the frequency, but you need to convert this into second. How do you do? Like 5 into 10 to the power 3, that is given in RPM, rotation per minute. Okay, so you need to multiply or divide this with 60. Okay, so what will be, let us first of all calculate our frequency of 5000 divided by 60. Okay, it will be 83 point, so the frequency will become 83.3. okay, hertz, means rotation per second, and its moment of inertia is this much, I is given. Okay, and friction in the axle provide an average torque they given. To slow down, how long does it take? So what, slow down, how long does it take for the blade to come to rest? So which mean, like the blade is running right now. Okay, so there is a friction on the blade over here. Right as switching off, the blade slowly come to stop. So how much time this particular blade will take to come to rest? Okay, so you need to calculate the time, delta t you need to calculate, and torque they have given, delta t they have given. Then what is to be, delta t they have given, torque they have given, then a moment of inertia, and angular velocity also they have given. Okay, so which equation are we supposed to connect? This is angular impulse angular momentum theorem. Delta torque into delta t will be equal to delta L. Okay, delta L. So how do I calculate delta L? Delta L will be equal to delta L final minus L initial. So what is L initial? L initial I need to calculate. What is L final? L final is easy to calculate. Let me write it over here. L final will be 0. Why? Because it is coming to rest. So L final is 0. But what about L initial? L initial, how do I calculate? To calculate L initial, this is what I need to look at the values given in the question. I value directly they have given Okay, and what about omega initial? Omega initial, they said it is 5000 rpm, that I have converted into rps in 1 second. Okay, so this is the frequency they have given as we did in the previous equation. So what we need to, this particular using this particular value, we have to calculate omega I. So finally what I'll get, I'll put the values together. It is 8 into 10 to the power minus 3. Okay, that is moment of inertia. Okay, and omega will become 2 pi f. 2 pi f will become 83.3. Okay, so when I'm putting all the values together, 83.3 multiplied by 3.14 multiplied by 2 multiplied by 8. Okay, so I'm getting 4.184. 4.184. So I'm getting the final velocity, final angular momentum, sorry, initial angular momentum 4.184. Okay. Now the torque is mentioned over here. How much it will be? It will be 2.3 into 10 to the power minus 1. Okay. Means 10 to the power minus 1, I can very well write it as 0.23. Okay. Now, how do I calculate the time taken? See, as we rearrange, delta t will become like delta L divided by torque. Okay, delta L is what? 0 minus this value. It will be the same only, 0 0.184. 0.184. There will be having a negative. Okay, no problem. You are calculating the time, so you can just ignore it. Okay, and time you can ignore, or torque you take it as negative. Okay, and 0.2823. Okay, so you just divide the value with the 0.2323, right? Yeah, 2323. So what you'll get, you will get 18 something, 18 point 18.19. See, look at this value is correct. Okay, oh my goodness, there is another issue. Moment of inertia they have directly given. Okay, that is also okay. Then diameter, the diameter is not making any sense over here. Torque they have given. Okay, and how long does it take? See, the final answer, it is come out to be 18. Okay, so there is no correct answer actually. Like let us make this one as 18.7. Okay, so this will be C will be correct answer. 18.19 will be the correct answer. So please cross check the calculation again. CLI will be calculated, the moment of inertia is given, and then we substituted omega I 2 pi f. Okay, and then we found the change in momentum. Change in momentum is exactly same value, 4.18. Okay, what else we have? Nothing, right? Yeah, then we equated that with the which one? The torque into delta t. Torque into delta t. Delta t we need to calculate. See, we divide that with the delta t, and finally we found the answer. Okay, this is it. Now we'll do the next question. In this question, a heavy door slowly rotates slowly because its moment of inertia is large. If the same door is redesigned with a lighter material, means the mass, or mass of the material has been reduced. Okay, so obviously moment of inertia will reducing its moment of inertia. Okay, by reducing the moment of inertia, what happened to the angular velocity? You know, they are inversely proportional. I decreases, omega will increase. Okay, same angular momentum. With the same angular momentum, what it would be? It will be increasing. Easy. Okay, now next one. A plane move in an elliptical orbit. At a closest point, the stars, its speed up. Which statement is the best? Explain this. See, look at. We have a star over here. Think of it, a plane is, this is a plane. Okay, this is a plane which is flying. This is a plane which is rotating in this particular path, elliptical path. Now look at, if the plane is near to the star, here the radius is less. See, if the plane is somewhere over here, the radius is more. Okay, so according to the question, a plane moves in an elliptical orbit at the closer point. If it is closer, it speed up. Why it is speeding up? Okay, so that is the question. So which statement is the correct? An angular momentum decreases near the star. Okay, angular momentum decrease. No, we cannot say angular momentum decreasing. And angular momentum increase near the star. That also we cannot say. Okay, angular momentum say constant, so the speed increases. That we can say from this particular situation. See, at near this particular star, radius is decreasing. For the system, the moment of inertia will undergo decreasing. So omega must increase, right? So which option can be correct? C can be correct. Okay, C will be the correct option. Now the next question. A physics student claimed the unit of angular momentum is kilogram meter per second. Is this correct? I think you are very well aware of right now. Angular momentum is having kg meter square divided by second. Okay, so which one it would be? B. Now the correct unit will be kg meter square per second. Okay. Now the next one, like a gymnast rotate around a bar with a constant with a moment of inertia 15 kilogram I they have given with an angular velocity omega I they have given during the dismount. He then reduced his moment of inertia to, see, when he pulled his body closer, like see, from this point to this point, the moment of inertia has been reduced to 3.9 kilogram. No external torque act on him. What is the new angular velocity? I think it's easy. This is the conservation of angular momentum. What is conservation of angular momentum? Like Li must be equal to Lf. Okay, this is the idea. What is Li? Li will be equal to I into omega I. What is Lf? I into omega f. So omega f. So I, omega c, I and omega I f and omega f. Okay, so I is given. This is the I and this is if. Okay, initially he was stretching and then he's turning. Okay, it's in the opposite. So turning it back. So initial moment of inertia is 15, and then angular velocity is 6, and then omega moment of inertia will become 3.9. I find this 3.9, and then this omega, you can put this x and you can calculate it. Okay, so what it would be, 15 into 6 divided by 3.9. Okay, so it is 23.0 something. Okay, so which one it would be? This will be the correct answer. Okay, now look at, see, based on this is the last questions in connection with the angular momentum and the conservation of angular momentum. Okay, we may discuss few more questions, numerical question related with that later, not now. Okay, now a spinning top rotate rapidly, but its axis is tilted. The gravity act on the top. Okay, the center of mass create a torque about the pivot. Why does the top begin to precise? Like, see, what is precision? Precision is nothing. When this particular object rotate, it will be making a circle like this. So they are asking why they are making a circle like this. So the actual reason, try to understand. When the top is tilted, the gravity is acting exactly down in this way. So look at, this is the axis of rotation, and this is the radius to the force. So over here what we have a torque. See, this torque will create a turning effect. As a result, it will rotate. Okay, so that is the reason behind that. Now, because of gravity only act on the top when it is tilted. Okay, and because a tilted top experience a torque that change the direction of angular momentum. Okay, because of X spinning faster always causes slide because of friction. No. So which one will be the correct answer? See, because of tilted top experienced a torque. Okay, it is experiencing torque, as a result it will be changing its direction, angular momentum direction. Okay, now see over here, look at this is the external force is experiencing. A gravity is an external force, so that create a change in momentum. Okay, so that because of that it will be. Now, why does a gyroscope, okay, you might have seen this particular device, gyroscope, okay, keep the axis in a toy helicopter and all, you might have seen this one. Gyroscope keep its axis rotation point in the same direction even when the device is moved. See, even though this is moving, like the axis of rotation and axis, it will keep in the same direction. Why it is? Because its mass is very small. It's wrong. Because it's friction? No. Like because the larger momentum resists the change in direction. Yes. See, as it move faster, it's have a larger momentum that will not be allow the object to change its direction. Okay, so C will be the correct answer. Now, see, this is the next concept. We call it as define closed system, isolated system, and open. Not open system is not specified, but still, like when you go through the textbook, you will see like open system, closed system, and isolated system. See, what is open system? Open system means you can just add and remove the masses if you want. Okay, but what about the closed system? Closed system means like you cannot add anything inside or outside. You cannot take anything in and out, but you can give force. Okay, so over here you can give forces. Force you can give, but no mass can be added or removed. But what about the isolated system? Isolated system, you cannot add or remove force as well as mass. You cannot give a force and you cannot give a mass. You cannot take a mass, nothing can be done. Okay, isolated system. Okay, so you can just try to understand a raindrop falling through an atmosphere gain a mass of water. So it is receiving mass. It's an open system. Okay, look at over here a closed system. Two pool ball colliding on a frictionless table. Frictionless table, nothing is there. It's an isolated system. See, no external force and masses are been involved. Okay, see over here, this is a container where the foot lid is completely covering the foot, so no mass can be given out or no force can be given to in. Okay, so this is an isolated system. Fine. There are certain questions in connection with a rocket in a space burn fuel and eject it back to the accelerate forward. Which statement is correct about the rocket during the burn? It's a closed system, it's an isolated system, it's not a closed system because mass leave the rocket, it's an isolated because no external force acting on it. It's not a closed system. Okay, it's not a closed system. Why? The mass is removed. Now, two skate pushes off each other on a frictionless ice. Again, frictionless comes. So which one it would be? More, no mass in the, it's a closed and isolated system, right? It's frictionless as we did in the case of a bowl, like two of them collide each other. We were not having an external force and external mass which has been involved. Okay. Now, the next one, a car brakes suddenly. A friction from the road act on a car. Is the car closed or isolated system? Of course, there is a friction, external force is there, and mass does not change, right? So what you can be, it's a closed system, but not an isolated system. So which one it would be? On a road, if you apply a brake, like a car will not lose its mass, but what will be a force is experienced outside. Okay, so that's what the closed system is all about. Okay, now the next one. During a soccer game, two players run towards each other from opposite direction and collide while trying to head hit the ball. They come to rest in a mid-air and fall to the ground. What can you conclude about the initial momenta? Their initial momenta were both zero. Their initial momenta were equal in magnitude and opposite in direction. Initial momenta were unequal, causing them to stop, and the initial momenta increased during the collision. No. Look at initial, see, right after collision come to rest, which mean what is to be noted, like the final momentum, P final is zero. See, according to conservation of momentum, what is to be noted? The next topic which we are going to deal it with the conservation of momentum. Okay, there we will be addressing it in detail, but still understand momentum before and momentum after must be same. Okay, so over here in this particular situation, like final momentum is zero, so initial momentum must be zero. Initial momentum must be zero. So P initial will be 0. But I cannot say that their initial momenta were 0. Their initial momenta were 0. That I cannot say. Why? Because both of them are moving. So this is wrong. So second option, look at their initial momenta were equal and equal in magnitude. They are moving in the opposite direction. So equal in magnitude and opposite direction. So which one should be? B will be the correct answer. Okay. A water tank is draining through a hole at a bottom. What type of system tank in a water? Say mass is losing, obviously it will be like an open system, not a closed system, because the mass is leaving. Okay, so D will be the correct answer. The law of conservation of momentum state the momentum of any closed isolated system, any conservation will be applied only isolated closed system. Okay, any closed isolated system change only in the object strike together, does not change momentum. They are asking about law of conservation of momentum, does not change. Okay, depend on the entirely on the frictional environment, always transfer. No, so which one will be? B will be the correct answer. Okay, transfer to the environment. No. So law of conservation of momentum state that the momentum will never change. That the momentum will never change. So the entire momentum of the system will remain same. Okay. Now we will discuss in detail about the conservation of momentum. We have left with only two more questions. Question number 22 and 24. Okay. So all the remaining questions we have completed. Okay. This is the last two questions. Question number 22 and 24. In question number 22, discuss the force and impulse exerted on the another case of two particle collision in one dimension. See, look at. Suppose a two ball A and ball B, they are coming and colliding with each other. Okay, so when they collide with each other, according to Newton's third law, we know it like force exerted by A and force exerted by B, both will be exactly equal. The magnitude of the force exerted by A must be equal to force exerted by B. So what is F A on B? Force exerted by A on B. Okay. And what is FB on A? See, force exerted by B on A. So this magnitude of the force must be equal. And what is to be noted, if you just multiply them with the delta t, the time of interaction, what you will get? You will get impulse, right? See, what is most important according to the learning objective, impulse should be connected with the two particle collision. See, this is what you need to understand. The impulse exerted by A and or experienced by A and impulse experienced by B, it must be equal. Okay, that is the common understanding you must have. Now, the equation, impulse momentum theorem and everything. Okay, now let us go to the next. See this impulse. See, impulse of A must be equal to impulse of B. See, as you equate them and rearrange, you will get another equation. We call it as conservation of momentum. So what is conservation of momentum? Momentum before and momentum after will be exactly same. Okay. See, as we said in the previous situation, impulse experienced by this object will be exactly equal to impulse experienced by this, right? So what you need to do, like this equation, you just need to like rearrange. So finally what you will get, you will get this particular equation. See, What is the idea of this particular equation? PCI. What is PCI? P means momentum, C mean C ball, and I mean initial. So this is the initial momentum of C ball. And what is this? This is initial momentum of D ball. See, what is this together we call it as, this is the initial momentum before collision. And similarly, look at the other PCF. What is P? Momentum, C ball, and F final. Okay. So this is the final momentum of which ball? C ball. And what is this? This is the final momentum of D ball. Now look at what exactly it will be. Like the final momentum and the initial momentum, they are equal. This is what we call it as law of conservation of momentum. And this question is connected with the law of conservation of momentum. Okay. Sometime like this will be a calculation question. Sometime it will be like a conceptual based question. What is the direction of velocity? What is the this things and okay. So let us go to the next concept. Question number 24. In question number 24, it's connected with a recoil. Okay. See, look at this particular situation. You are standing, or two persons are standing, like both of them are wearing skating shoe. See, initially they are not moving. So what is the initial momentum? Initial momentum is 0. Okay, they have only final momentum over here. Okay, so what is the specialty over here? See, both the persons will be having a momentum after. So what is to be noted? See, if you are calculating the momentum of this person and this person, see, there will be magnitude wise equal. So if this is having a 50 kilogram meter per second, and this also will be having a 50 kilogram meter per second. But if this is positive, and this must be negative. See, before, what was the total momentum? It was 0. See, after pushing them each other, what is the total momentum? Look at, when you add it together, you will get it 0. So before and after, what will be the total momentum will remain same. Still in this situation also, what is conserved? Momentum is conserved. Okay, based on that, like this particular situation, we need to calculate the velocity of recoil. For example, I'll take an example over here. Look at this second situation. An astronaut initially at rest. Okay, there is the initial momentum will be 0. So right after firing a bullet will be moving very fast. Okay, mass of the bullet, let me call it as m. Okay, and velocity of the bullet, let me take it as v, a small v. And similarly, the mass of the gun or the entire system together, let me call it as capital M, and velocity of it will be capital V. So what is the idea behind this? See, generally they will ask you to calculate the velocity of recoil. Okay, velocity of recoil, how do you calculate? This is what we need to understand. See, mass of bigger object into velocity of that object must be equal to minus of mass of the smaller object into velocity of that particular object. This is the equation. Okay, here I have specified this equation. This is exactly same. Okay, now these are the key idea. Look at, the lighter skate move faster because velocity is inversely proportional to mass. We know it. Okay, and how to identify the mass differences? Like like the bigger one you take one, and the other one take the smaller. Okay, now we will go to the next slide, and we are starting with the questions in connection with this two concept. Okay, so that you will get an idea. Fine. Now, first, look at, two inline skaters are standing completely still facing each other. Skater C pushes skater D. Okay, and we know that they are standing still means momentum initial will become 0. Both moves in the opposite direction because push was internal force. They are giving force internally. Not, see, suppose I am a third person who is coming and pushing them, this conservation of momentum will not work. Okay, only when the conservation will work, if they push themselves, then the conservation will work, which means the momentum before and after will be same. Now, right after pushing them each other, they are moving with a different velocity. Okay, they have momentum right now. What happened to the total momentum of the system? Total momentum of the system, what it would be? This is what I said with the previous situation. I took, if this is a 50 kilogram meter per second, and this also will be 50 kilogram meter per second, but one will be positive, another must be negative. So when I am adding them together, the net momentum after collision will be 0. Okay, P final also will be 0. So let us look at the options. It become positive in the direction of the heavier skater. It's wrong. Don't ever think that the total momentum is more for the person. No, like total momentum of the system, what was before and right after pushing them each other, we will get exactly the same. Okay. Now it become 0. Yes. Why? Because initially it is 0. So right after that also it must be 0. Okay. Because there is no external forces have been happened. That is double due to no. It's also wrong. Now next, in the scenario above the same situation, what is the initial total momentum of the system before the push? See, what is the initial total momentum before the push? Easy, right? What it would be? Like, as they are not moving, the momentum for the first person and second person is exactly 0. So it will be 0. Okay, see. Now, let us look at the next one. A clay ball mass m traveling a velocity v hit a stationary target of mass 3m and stick to it. What is the final velocity of the system? Okay, understand, like we have a stationary object over here which is having a mass of 3m, and then we have a ball, a clay ball, which is having a mass m, and it is initially moving with a velocity v. Okay, now this is the case which is before. Now let us calculate the momentum before. Okay, so momentum of this particular object, let me call it as this is one first object and this is second object. Okay, so P1i, what is P1i? P1i is just mv. What is P2i? P2i is exactly 0. Why? This is not moving. Okay, this is a stationary. Okay, now right after collision they are sticking together. So what is the total mass of the, see, as they come and collide each other, they are sticking together and then they are moving with the velocity. We do not know what is the velocity. Okay, and their mass, we know how much it will be. It will be 4m. So right after collision we have only one object, so that object will be like having a mass of 4m, and what will be the momentum? So P final, I would say it will be mass is 4m into velocity. Velocity we do not know. Okay, I'll put it as x. Now what do they demand? Look at, they are demanding about the velocity of final velocity, velocity of the system. So velocity of this we need to calculate. Okay, so how do we do? Look at, see, we know that according to conservation, P initial must be equal to P final. Okay, so what is P initial? P initial, you need to add this together, but 1 is 0, so obviously P initial will become P1 initial. How much it is? It is mv. Okay, only this will be counted for P initial. And what about P final? P final will become 4m into v. Okay, now what you need to calculate, or like put it as x, you need to calculate x, right? So you keep the x over here, so you just divide this with 4m and this also with 4m. So what it will be? M and m will get cancelled. V by 4 here, like x, I will be getting it as v divided by 4. Okay, so which will be the correct answer? This will be the correct answer. Now let us look at the next question. The law of conservation of momentum for an isolated two-body system can be written in terms of change in momentum. Again read. The law of conservation of momentum for an isolated two-body system can be written in terms of the change in momentum. Yes, we can write it. Okay, of a body. Which of the following expression is correct? Okay, so like we have a two particle, like particle 1 and particle 2. Okay, now see, the particle 1, it will be having a momentum before and right after collision they will be having a momentum after. Okay, so let me say delta P1 is the change in momentum of the particle 1 and delta P2 will be the momentum of the change in momentum of the particle 2. Now what is to be noted according to Newton's third law? We know it like force exerted on this one will be equal to force exerted on the other, right? Similarly, if forces are equal, then their change in momentum must be equal. Okay, so over here they are equal, but one thing should be known, like one is exactly opposite in magnitude, opposite in direction. Okay, so delta P1 is equal to minus delta P2. Now which one will be satisfying this particular relation? Look at the first one. See over here delta P, the magnitude wise they will be equal, but what is to be, the problem over here, we don't have a negative sign. Okay, suppose if you just add this with a positive delta P2, okay, and here also you just add positive delta P2, so what you'll get here, you will be getting it as 0, and here you will get delta P1 plus P2. So which is the possible answer over here in this one? The change in momentum of the first one plus change in momentum of the second, together you add, you will get it as 0. So this is the second option that is the correct answer. Now look at the next question. A 0.5 kg ball traveling at a speed of 6 meter per second collide head on with 1 kg ball moving in an opposite direction. Okay, at 12 meter per second after colliding, the 0.5 kg ball bounced back 40 meter per second. Find the other ball's speed and in the direction after the collision. So a very good question. Like over here, see, such a question comes, what is important, you should draw the figure so that you will get an idea. What is the initial situation? We have a ball which is having a 0.5 kg mass. Okay, and it is traveling in one direction. Let us take it as this direction and this direction, and its velocity is how much? Its velocity is specified it as 6 meter per second. Okay, now we have another ball which is coming in the opposite direction. Okay, this is little heavier. Its mass is 1 kg and it's moving in the opposite direction with double of its velocity, 12 meter per second. Okay, so what is to be noted, like both the object have momentum before. Let me call it as this is 1 and this is 2. Now first of all, let me calculate the momentum before and then I'll calculate the momentum after. Then I'll be equating the values which is to be calculated. So over here, initially all the quantities has been given. So I need to calculate the momentum of this ball. What is the momentum of P1 initial? P1 initial will be mass into velocity. So how much it will be? It will be 0.5 into 6. So 0.5 into 6 will become 3. Okay, 3 kilogram meter per second. Now what will be P2I? P2I will become, I'll write it over here. P2I will become, mass is 1 kg, 1 into velocity will be 12. Okay, I'm not writing the equation, momentum will be calculated mv. Okay, so 1 into 12, 1 into 12, it will become 12 kilogram meter. Now what is speciality? Like, see, this is moving to the right side, so this must be positive. And what about this one? This one must be negative. Okay, this is must be negative. Now let us read and continue. Like after colliding 0.5 kg, okay, so they collide each other. After collision, the 0.5 kg is returning with a velocity of, see, backward with a velocity of 14 kg. Okay, 14 meter per second. So over here, this is the first ball. And what about this second ball? Second ball 1 kg, what will happen? What is the velocity? The velocity of the second ball we need to calculate. We do not know. So what they have not specified, the final momentum of the second ball they haven't specified. Final momentum of the first ball they have specified. How much it is? Look, final momentum P1 final. How do I calculate? Mass is 0.5 multiplied by 14. Okay, so when you multiply it together, you will be getting it as 7 kilogram meter. But the problem over here, look at, see, this is returning, so the velocity will be negative. As a result, we will be having a negative momentum. Okay, now which equation are we supposed to connect it over here? See, the momentum before and momentum after must be same. Okay, that is the equation. So let me write the equation. P1I plus P2I will be equal to P1F plus P2F. Okay, now let me put the value. P1I, I know it's 3. Okay, what is P2I? We calculated it's minus 12 kilo 2 minus 12. Okay, minus 12. So even though this is positive, like positive into negative will become negative. Okay, so over here 3 minus 12, it must be equal to, what is P1F? P1F is minus 7. Okay, plus, what is P2F? P2F we do not know. P2F, how do you calculate P2F? P2F will be equal to M mass, I know it's 1 into X. Okay, we need to calculate. So over here I'll be mentioning in such a way that I'll be putting 1 into X will be just X. Okay, so mass is 1, so I'll be just multiplying 1 into X, it's 1x. Fine. Now over here, see, you can rearrange the equation and or shift solve, like you will get the answer. 3 minus 12, 3 minus 12 will become minus 9. That will be equal to minus 7 plus X. So finally what you will get, this 7 will go to the other side, it will be adding together, and X will become minus 2. Okay, so the velocity of the second ball, X, will become minus 2 meter per second. So what is this negative indicate? So this indicate it will be in the opposite direction, negative direction. Okay, original direction of which one? Original direction of heavy ball. Now let us look at, see, we have 2 and 2, so 8 and 8 is wrong. So 2 and 2, 2 meter per second, 2 meter per second, 2 meter per second in the original direction. Okay, so 2 meter per second in the original. See, we are calculating the 1 kg mass velocity. 1 kg mass velocity, it was moving before in this direction, and now it also moving in the same direction. So which one will be the correct answer? So 2 meter per second in the original direction of that particular move. Okay, so 2, that is the correct answer. Now let us go to the next question. See, in this question, this is the Newton cradle. You are aware of it, right? It has a ball on the equal masses suspended in a line. When a ball A is lifted and released, it swing down and collide with the ball B. Okay, okay. It's coming and colliding with B. And after the collision, the ball A stops and eventually the ball E swings. Okay, you know that as it come, this will be coming to rest and it stay over here, and then E will go. Okay, now after a ball collide with B, the process repeated through the cradle, and which currently releases the velocity of the ball A and E. See, like select the correct option. So what will be the relation between velocity of E and the velocity of A? Of course, they will be equal, right? Velocity of E will be exactly equal to velocity of A, and which is correctly relate the velocity of ball A, okay, and with V. Of course, like what velocity the A comes, if this is 5 meter per second, and with the same velocity E will go, and this is what we call it as conservation of momentum. Okay, and this also will be 5 meter per second. So which option? First option will be the correct answer. Now, a white ball, billiard ball, strike stationary billiard ball during a collision with a white ball exert a force of 800 Newton, and the red ball is positive direction. And what is the force does the red ball exert on the white ball during the collision? This is white and this is red. When they are colliding with each other, we know both of them will have the same force, but which is in the opposite direction. So which one it would be? 800 Newton in the opposite direction. Okay, 800, exactly 800 Newton in the opposite direction. The last question. During the tennis serve, a racket continue moving forward after it hits the ball. It's the momentum conserved in the collision between the racket and the ball. See, after hitting the racket, okay, so racket, even though you finish the contact, still the racket will be moving still forward. Okay, so in this situation, the conservation will be valid or not. Conservation of momentum will be valid or not. That is the question. Okay. So what is the idea? Conservation, wherever we have a collision, there the conservation of momentum will be valid. Okay. So as the momentum is always conserved for each object individually, you cannot say that it's each object individually it will be conserved. The answer, yes, that part is correct, but each object individually it will not be conserved. Okay. So yes, the momentum is conserved as a system. Okay. The ball and the racket together will considered as a system. So ball and racket, what was the momentum before? And that will be exactly same as the momentum after. So which option will be correct? This will be the correct option. Okay. So let's go to the next. See, define a system. Okay. Now, it's a question connected with a 24. A 187 kg car moving at a speed of 23 meter per second in a rear ends rear end. 1025 kg car moving at 17 meter per second on a frictionless ice. The car stick together. Which statement correctly describes the system of applying momentum conservation? Okay, again let me read. A car 1875 kilogram is moving at a speed. Okay, this much speed it is moving in a rear end, back end. We have another car moving 17 meter per second on a frictionless ice. Okay, the cars stick together. So these two cars collide each other and stick together. Fine. Now, which statement correctly describe the system for applying the momentum conservation? Now, we are talking about the conservation of momentum. Okay, only a heavier car, only a lighter car, both car together because no external horizontal force are acting, both car and ice surface. So which one it would be? It will be C. Like there is no external force is happening over here. There is a frictionless. So obviously both the car together, no external forces are acting on it. Okay. Now, second one, an astronaut firing a thruster pistol. Okay, like we know it. An astronaut fire a thrust that eject a gas backward. Okay, astronaut move forward. Okay, what is the momentum conserved? Sorry, why is the momentum conserved? Why the momentum is conserved? So why the momentum is conserved? Understand the situation clearly. Like over here we have astronaut. Okay, like they are firing gas. Like let me call it as this is the astronaut engine. They are sending like a fume or gas outside. Okay, and similarly like who will be moving forward? This will be moving forward. So what is the change in momentum of the gas must be equal to the change in momentum of the astronaut. Okay, that is the idea. Because the astronaut gain mass, because the gas and astronaut form a closed system. Yes, exactly. See, together this should be considered as a closed system. So there is no external forces coming. So if this is moving in this direction, this must move in the opposite direction to conserve the momentum. So which one it will be? B will be the correct answer. Now, next one. Two students in a skateboard push off each other, move in an opposite direction. Which statement is true? The heavier student move faster and the lighter student move faster. and both students move in the same speed and momentum is not conserved. See, momentum is conserved. Okay, both students move in the same speed. No, the heavier student move faster. Obviously, that is wrong. So which one it will be? The lighter student will be move faster. Okay, now next one. A person standing in a small boat throwing a ball forward. Okay, what happened to the boat? Okay, think of it, you are in a boat and you are throwing a ball outside. Okay, so obviously you are giving a force in this direction, so as a result we will have a recoil. This boat will be moving in a backward direction. Okay, so that you should remember. It moves forward because the momentum increases. Obviously this is wrong. Like, see, if the boat move in this direction, boat should move in the opposite direction to conserve the momentum. Okay, second one, B. It says still because of the small, it's so small, we cannot say that. Like, it's in the boat will be in the water, so friction will be comparatively less, and obviously it has to be moved. So this is wrong. It moved backward to conserve momentum. So which one will be C? Will be the correct answer. Now next one. An astronaut is at rest in a space and fire a thruster piston that expel 35 gram of gas in 875 meter per second. Okay, and the combined mass of the astronaut will be 84 kg. What is the astronaut resulting speed? In which direction it will be? Look at. See, we have an astronaut, and as at the beginning we saw a picture. Okay, he is firing a gun, and see, the gas expelled outward will be equal to 35 gram. Okay, and obviously the mass is very less, so we will be considering it as small mass. Okay, and moving at a velocity of 875 meter per second. Okay, so mass and velocity of the small object is being given. Now what we need, see, big object mass is given, how much it is, 85 kg, and then mass velocity also we need to calculate. So which is the equation? We know the equation, recoil velocity, or we have equation capital M into small v, capital V will be equal to minus into small m into V. Okay, so what do you need to calculate? You need to calculate this one. So you take capital M down, and here also you will just divide. So finally what you will get? You will get capital V will be equal to the velocity of the astronaut will be equal to negative into mass of the gas which is expelled. So it is given in grams. So first of all you need to convert that into kilogram. So what you do, you will be dividing this with 1000. Okay, so when you divide this with 1000, you will be getting it as 0.035. so the mass will be 0.035 multiplied by 875. Okay, don't interchange the velocities. So once you interchange the velocity and mass, you will get a wrong answer. Okay, and then 84. Okay, capital mass is 84. So put in the calculator and find out the answer. So over here, what would be? Let me just write it in the calculator. 0.035 into 875 equal to whole divided by 84. Okay, so it will be 0.36. Okay, 36 meter per second. So 0.36. And what is negative? Negative means in the opposite direction. Okay, it is already in backward, so it's in the opposite direction means forward. Okay, so which one it would be? Like, see, the gas is moving backward. Understand it clearly, gas is moving backward. So as we know, according to the equation, we have a negative. So our direction will be exactly opposite to the direction given in the question. So which one will be the correct answer? It will be 0.36 meter per second forward. Okay, now like this is another question. A 187 kilogram car moving at 23 meter per second in rear end at 1025 kilogram car moving at 175 on a frictionless ice. the stick together after collision, what is the common speed immediately after the collision? Okay, so like the problem over here, say I have one car, another car, see this is moving at a 23 meter per second and this is moving at a 17 meter per second. Okay, rear end means back side, so one after the other. Now look at, if they collide each other, see the problem over here. See, what is the confusing part of this question, if this is at the front and this car must be at the back side. So if this is moving at the 23 meter per second, if this is coming with the 17 meter per second, this will never collide each other. Okay, so that is a problem. So what can be done, this question itself is having certain like issue in the design. Okay, so over here what I can do, like I'll just switch this in the opposite way. Okay, this is at back side and this is at the front side. Okay, so this is the first car and this is the second car. This is, I am using the first car and this is at the second car. Okay, now so what we know, according to conservation of momentum, momentum before and momentum after will be equal. So I'll write the equation. So P1I plus P2I must be equal to Pf. Why Pf? See, after collision they are sticking together and moving with the velocity. So after collision they are colliding with the like sticking together and moving with a single object. So its velocity we take it as v. Now how do I calculate P1I? See, the mass of first object is given how much? It is 1 0. Even if you interchange it, there is no problem. 1025. Okay, and what is its velocity? It's 70. Okay, plus what is the second? 1875 and it's moving into 23. Okay, this together will be having they are sticking together. So what is the total mass? Total mass will become, I need to add these two masses together. So 1025 plus 1875 together I'll add. So I'm getting the mass of the cars together will become 2900. Okay, into x. I do not know. So you put it in the calculator, shift solve, you will get the answer. Okay, let me put in the calculator and check what is the answer which I am getting. So 1025 into 17. So how much I am getting? 17. I'll write the calculations somewhere over here. I don't have space over there. So when I'm multiplying it together, I'll be getting 17425 plus 1875 into 23 multiplied by 23 will become 43125. Okay, plus 17425. So it will become, the initial momentum is 60550. Okay, that will be equal to 2900 into x. Okay, so what is x? X will become 2900. It will be 20.8. So we don't have that value, 20.8, which we are getting. And in which direction we are getting? That is another, in the same direction. Okay, in the same direction. So it will be 20. This will be the correct answer. 20.8 it would be. Okay. Now the last question for this particular lesson. Look at the following diagram. Show two identical billiard balls before after collision. Okay, So this is coming like this is a positive velocity and this is a negative velocity. Okay, their masses are identical. Okay, so the calculation will be much easier in this situation. Okay, and the if masses are identical, then this is the equation. If masses are identical, V1I plus V2I will be equal to V1F plus V2F. This is the equation. See, like let us just connect it with. Let me read the question completely. The blue ball moved to V0 in the positive direction right side collide directly with the ping ball which is moved in at V in the opposite direction. Okay, in this direction, left side. After colliding, the blue ball moves left with V. So blue ball is moving with a V. So this is negative V and this is negative V, V0. Okay. And what is the speed of the ping ball after collision? Okay. So let us put the values over here. So this is positive and this is negative. This is negative and this will be what we need to calculate. We put it at X. So as I am putting value over here, so this let me mention it as 2V, 2V0. Okay, 2V0 plus minus will become minus, it will be V0. Okay, will be V1F will be what? V1F will become, and let me just say this will be considered as a first object and this is considered as a second object. That's what I have put, like V1I will become 2V0. Why I'm not mentioning M, see, everywhere M will be there, M will be cancelled. So if the masses are identical, then it's much easier to do. Okay, now like again so what will be V1F? V1F is minus V. Okay, minus V0. Okay, and what we have V2F, we do not know, this is X. Look at in the left side and in the right side we have minus V0. They can cancel it each other. So finally what I'll get X is equal to 2V0. So this will become 2V0 in which direction? To the right side. So 2V0 to the right, that will be the correct answer. Now, the last one. A billiard ball moving with a velocity of 5 meters per second to the right collide with a stationary identical billiard ball. Identical billiard ball is exact same situation. Masses are same. So masses are same means we will be using this equation. Okay. Head-on collision. Head-on collision means in a straight line. Head-on collision, try to understand, in a straight line collision we call it as head-on collision. Okay. After collision, which of the following is the correct answer? Now, see, again what we need to say, like V1 X, okay, V1X I plus V2X I will be equal to V1XF plus V2XF. Okay, so this is the equation. Now what is given? This they given, it is 5 plus this is given, this 0. Okay, now we do not know what is the value of this and the value of this, but what you can do, like before what was the value, right after collision also you have to get the same. So look at in the first option, when I am adding these two together, what I am getting exactly 5 I am getting. So actually this is the correct answer. In the second case, look at, it's plus and minus. If I am adding them together, what I'll be getting? I'll get 0. See, it should not be. When I am adding this together, I should not get what? I should not get 0. So this option is wrong. Try to understand, like we don't have two values which is not given, but this is another way of understanding. Like you know that before collision what was the velocity? It's 5 together, and right after collision also what must be? It must be 5. So when you add the velocities together, you should get it's 5. That's it, nothing much. Fine. Now this is, look at, when you add this together you will get minus 5. So obviously that is wrong. Okay, this you will get 0 again. So this is minus 5 and this is 0. So this is 0, 0 is wrong, and plus 5 we got before. So which is the correct answer? Plus 5. This one is the correct answer. This is wrong. Okay, so with this we have concluded the calculation questions and everything related with the EOT. Now we are starting with the extra questions. Okay, so um, watch the video clearly and study properly, and right after we'll do the extra questions together. Okay, okay. Thanks for watching. Bye.